Okay, so let's start it. So hello everybody, and thank you for joining us today. My name is, okay, so hello everybody, and thank you for joining us today. My name is Ferenc Spala, and my friend is Laszlo Toth, and we are going to talk about database security. But please note that this is the last SQL injection in our presentation. I know Dan Kaminsky established that SQL injection is not going away. He's right, he's absolutely right, but not in this presentation, because we want to show you it is worth thinking differently about database hacking. I guess you have already figured out we are not Americans. Yes, you are right. We are from Hungary. You know, Hungary is located in Central Europe and the homeland of several IT celebrities. Like,
far, far away in the galaxy.
Yes, far, far away. John von Neumann, who invented the modern computer. Charles Simonyi, the father of Word and Excel. Okay, he's a Microsoft guy, but you know, we all use Word and Excel, so he's a good guy anyway. And Mark Zuckerberg. Okay, it's not true, but his dog. And he's really cute anyway.
Hungarian pulley.
Yeah, so if you want to feel like a billionaire, buy a Hungarian dog. But what we have for you today, we have 4 different topics from 4 different words. First, hacking the Oracle client. We will show you some tricks. It's some kind of post-exploitation, you know. So what are your options if you hacked a database administrator workstation, for example? And then we move to network level. And we will show you how to hijack live Oracle connections. Then we play a little with Aura Debug and Metasploit. And last but not least, we show you some tricks from the Microsoft world as well. But first things first, hacking the Oracle client. We did some research on the #1 Oracle client driver called OCI, and we found some really interesting things. And yes, we are talking about client-side hacking. We are talking about driver hacking. And yes, this is DLL injection. And I know DLL injection is pretty old. I mean, every little kid can inject his DLL into any process. Not a big deal. Furthermore, the OCI driver ships with its symbol file. So it's really easy to debug. It's really easy to identify the connect functions in the OCI driver. So it's not so good, but so boring. You may say that. And I'll show you why. All you have to do is debug the OCI driver. You know, it's a piece of cake, as I mentioned before. Identify the interesting functions. I recommend 2 for you. The first one is OCI auth set. And it is called every time when a username or a password is passed from the client to the driver. I mean, password in clear text. The second one is OCI server attach. It is called when other connection parameters like IP address, port, or service identifier is passed from the client to the driver. So these 2 functions is a really good start. OCI is written in C, so you have to do some memory kung fu. You will find a lot of pointers in the OCI driver. But that's all. So you can implement your own versions of these functions. You can wrap up your DLL, you know, write or download a piece of code for injecting and function redirection, and that's all. But the problem is, in most of the cases, you will get nothing because you inject the connect functions, you know. So you have to wait for the user to enter his credentials. If you miss that, you will get nothing. So it's not worth talking about at DerbyCon. I know that. So we kept going, and we found something really weird. It is possible, not the cat, but he's weird too. So it is possible to get the username and the clear text password from a single SQL statement execution. Every time when a user executes a select, insert, update, anything, you can steal his username and password. There is a function called OCI statement execute. Remember this function, it is your friend. Because, it's a screenshot from Oli debug. because in every hacker presentation, there must be a screenshot from a debugger. So here it is. We set a breakpoint to OCI statement execute, and we are interested in its first parameter. It's a pointer, of course. If you follow that pointer, you will get an OCI structure. In this structure, there is another pointer. What a surprise. Follow this one, and you get another OCI structure. But in this one, if you take a look at this area, you may find another pointer. But this one points to the username. I mean, username in clear text. No more magic required. If you follow this pointer, you get the username. The next byte is the length of the username. The next byte is a marker. Next 8-byte block is an encryption key. And guess what? The remaining part is the encrypted password. So what's the wrong with this picture? You got the encryption key. You got the encrypted password. Only one thing is missing, the encryption algorithm. And guess what? This is DES. Because DES is the favorite encryption algorithm of Oracle.
And you should remember about of the marker, because if you see this marker in Oracle and some bytes after it, you can make sure it is a dash encryption and the first 8 byte is the key.
Yeah, Oracle loves DES, and we love too, of course. So the main problem is this is not client specific. I mean, this flow lies in the OCI driver itself. Every single Oracle client that uses the OCI driver is affected. And it doesn't really matter what do you do as a programmer. You can clear up everything from the memory. The OCI driver stores the username and the password in this way. And of course, we have a live demo. I hope so. So give it a try. We implement this whole OCI stuff as a Metapletter extension, because we love Metapletter and we love Metasploit. Here is the victim machine. As you can see, it's an Oracle client. Oh, so as you can see, it's Toth, a well-known Oracle client. The user has logged in, so I can run SQL queries, for example. So there won't be any login. And take a look at the attacker. Here is our Metapletter session. I mentioned this is a post-exploitation technique, so we somehow gained our Metapletter session. All we have to do is search for the Oracle client process. Yes, here it is. We need the process ID, and we migrate into that process, if I remember well. No. Almost. Yeah, it takes a few seconds. It is standard Metapletter Kung Fu. And we load the OCI Oralog Metapletter extension. And I show you the log file, because I'm not cheating. As you can see, only one line, some kind of debug message. But I say, OK, let's hijack the OCI statement execute function. Completed. And now we are just waiting for a single select. Let's do it. Most simple select in Oracle. And if you, yes, username and password. By the way, we got the select as well, but who cares? I mean, we got the username and the password. But this is just the beginning, and let's move to network level with Laszlo. I just clean up everything, and let it go.
Okay. Thanks, Ferenc. Hello, everybody. Let's move to the server side, and let's see why we can talk about the hijacking Oracle session. History. In 2009, I released a tool called Python-ish proxy. It had many features. For example, it was able to hijack the Oracle sessions. You will see how later. It was able to downgrade authentication protocols. For example, in the case of JDBC, it was able to downgrade the oldest AES-based protocol to the newest AES-based protocol to the oldest DES-based one. And it was able to log authentication data for offline brute forcing for John Doe repair and wore-out BF. Everybody should heard about the second main event, the TNS poison attack, which was released because of a communication glitch between the Oracle and the researcher. So Yoxin, correct, I hope I pronounced the name well, released a great research paper and a working proof of concept code. Both tool has its own limitation from certain point of view. In case of PyTNS proxy, you have to somehow convince the client to connect to the proxy. You can do this with the classic bar cache poisoning and some IP tables kung fu, meaning port redirecting, so the typical transparent proxying stuff. The working proof of concept code has a very serious limitation. Of course, it's a proof of concept code. It can handle databases with only 6-character long service identifier. But what are we talking about? So in Oracle, there is a listener process, and the listener process is responsible to handle the network connection. After the initial connection setup, the listener starts a new Oracle process and hands over the connection to this newly started Oracle process, and the Oracle process will handle the authentication and data exchange. In a clustered environment, the listener process is responsible to redirect the client to the given Oracle instance. And the databases can say to the Oracle listener, hey, I'm registering, I can serve this service identifier and this port and this IP address. And the main problem with this register communication, it doesn't have any authentication in it, which means anybody can send register communication to the listener, and the listener will accept it even if it is a standalone Oracle configuration. So how it looks like, TNS poison sends its register communication, and when the victim tries to connect to the listener, it will be redirected. Of course, just certain percentage of the clients will be redirected because the oldest instance in the cluster environment will receive still connection. So the client will be redirected to an attacker-defined IP address and port. And if you have a right tool, and the TNS poison has a proxy tool, the TNS poison proof of concept code has a proxy tool, you can forward every packet to the database server, so the connection goes through you, so you can do anything with it. And the main message, there is no patch for this one. And it won't be in the near future, or it will be in the next version of Oracle, which will become in the next month or until end of the year. Okay, as I already mentioned, you can redirect a certain percentage of the Oracle clients. The traffic goes through you, so you can do anything with it, sniff it, alter it, or you can send your own SQL commands. But how? And this is where PyTNS proxy can help you. How it works, TNS poison sends its register communication. When the victim tries to connect to the listener, it will be redirected, and every packet will go through the PyTNS proxy. As simple as that. In the TDS protocol, there is a quit message. When the client sends the quit message, PyTNS proxy won't send the quit message to the server. Instead, it starts a new thread and waits for the connection. An attacker can connect to this thread, and the thread will simulate the initial connection setup, simulate the authentication, and when the attacker sends a SQL query, the SQL query will be forwarded on the same connection and on the same socket that was used by the victim, which means when the server receives the SQL query, it will be run in the name of the victim. And because of the simulation stuff, you can use Oracle, the normal Oracle client as an attacker, of course with some limitation. So you can execute SQL commands in the name of the victim, and we have a live demo for that also. Okay. As I already mentioned, the TNS poison proof of concept code has this limitation for the 6-character long service identifier. Therefore, I developed the Metasploit module that doesn't have this. So the maximum length of the service identifier is 12. So this Metasploit module will support all possible service identifier lengths. It's quite simple, as you can see. I'm just set the target database, and the connection will be redirected to this IP address and port, and PyTNS proxy will wait for that. But before I'm starting this module, let's see what is the situation at the server side. As you can see, this listener serves this service identifier with just one instance, and that instance is a local server. Let's run the module.
And just see that you don't need username or password to do that.
So it's
just the IP address and the port and the service identifier
of the Oracle, yeah. And let's check out now. And as you can see, this seed now has 2 instances, and one of the instances is a remote server, and all of the communication or some percentage of the client will be redirected to this IP address and port. As simple as that. Okay, let's try to connect to this Oracle. With a very strong password. As I already mentioned, a certain percentage of the victim will be redirected. So we have to do this a couple of times until we will be redirected. And we just redirected. I know this because of the slide delay. If you check, so I just tried to connect it to the Oracle server, but now I'm connected to the PyTNS proxy. You can see this from the logs. As you can see, all the communication will be forwarded to the original database server. And of course, you can do anything with this connection. So the victim just starts work. And after, when he finished his work, he can exit. As simple as that. But now, as you can see, a hijack thread just started that waits for connection on this port and says to you, you have to use this client on Windows, this version of client on Windows. So let's connect to the hijack thread from the attacker machine. You have to use this static username and password while you connect to the hijack thread because of the authentication simulation. But this user doesn't exist in the database, in the target database.
Believe us, not exist.
As you can see, we just connected. Let's issue the whoami command. Okay, the attacker should know the SQL language. And we are the sys user. So we successfully, here it is. We are the sys user. We successfully hijacked the connection of a sysdba user. Why we just try to log in with this username and password. Okay then. So now after this, so some notes. As I already said, you have to use same client version that the client used. Use the proxy test username and password while you connect to the hijack thread. But because there is some security you have to do this because there are some security measurement at the client side of the Oracle. But you can switch off that security measurement with the sysdba. After the talk, I can show you how it is working. You have an easy-to-use Metasploit module now for the TNS poison attack. So you can use it, feel free. And you can already download our tools from our website. So you have the link at the end of the presentation. In a complex Oracle installation, might be global database ID is used. In that case, more test is needed from our side. Okay, so you already hijacked an Oracle connection. And if you are lucky enough, as I was in the demo, you hijack the sysdba connection. From this point, you can use the already back programming language to escalate your privilege further or hide your presence. And everything can be done in a Commodore 64 style. You will understand why. History. David Lichfield showed how can you use the ORA-debug command to run operating system level command. In the same year, I showed how can you do this in a much simpler way. And I showed how can you switch off the audit in the Oracle database, the sysdb audit and the normal audit also. And even I showed how can you switch off the password validation in Oracle and Windows. So mainly just backdoored Oracle, and you can log in with a good username, but with the wrong password. But what is it? So ORA-debug is a simple command that can be called from SQL+. It can be accessed by sysdb only, but we're talking about the post-exploitation phase, but anyway, we just hijack the sysdba connection. Everything is logged in a trace files in case of ORA-debug, but it can be accessed by sysdba and you can delete it. So you can hide your presence, or you can switch off this usage. And there are two very useful functions for an attacker. You can call any function that is accessible from the Oracle executable. And you can write the Oracle process memory. Of course, you can read it. So yes, you have arbitrary memory write and execution. So the holy grail of exploit developers. So this is how can you switch off the sysdb audit or the normal audit. Of course, the address is dependent on the given version, but later I'm going to show you how can you switch off the sysdb audit without the memory address. And as you can see, we are using the poke commands, subcommands, to write into the Oracle memory. And this is how easy to run an operating system command. We're just calling the system API. The trick is you have to use tab instead of spaces, because ORA-debug thinks or assumes a new parameter after the space. So you use tab on Windows, or on Unix system, you can use the $ifs trick. And this is why are we talking about the Commodore 64. In the ancient time, the Commodore 64 memory was manipulated with the peek and the poke command. Just we are doing now in the Oracle world. So Commodore 64 1982 vs Oracle 2012. The same methods. I received this screenshot from Peter Sir when he just presented about the virus past, present, and future. So this is the future. Okay, anyway, but so the example. So the sysdb audit is used when a user is logged in, and it is logged in as a sysdb, and all of his actions will be logged. It is very important in Oracle world, because the sysdb is the highest privilege in Oracle. There is a parameter called audit sys operations. It is an initialization parameter that can be used to switch off or on the sysdb audit. And as you can see, you cannot switch off this parameter while the database is running. Of course, you can switch off in the SP file, just add the scope equals SP file to the alter system command, but you cannot do this while the database is running. But you can do this with the ORA-debug at the bottom of the screen, because this parameter is a variable in the system global area. And the ORA-debug set for subcommand can be used to manipulate these variables, so you should set it to 0, and you can do anything you want. Your presence will disappear from Oracle. Okay, until now everything was history. What is the new things here? The new things that we just developed the Metasploit library or core mixin that simulates a Linux 32-bit client for the given version of servers that you can see on the slide, and runs ORA-debug commands. And based on this module, we developed a command execution module and a payload execution module, because we have arbitrary memory write and execution. And of course, we have live demo for that. So we don't need the redirection anymore. And let's start with the execution. As you can see, it's quite simple. Setting up the target database with a sysdba username and password. And here it is, the command. I'm using the $ifs $ here because I couldn't figure out how to add tab character to the MSF console. Anybody? And so the module will replace $ifs $ with tab. But I'm going to show you I'm not cheating. So on the server, there is only two users, administrator and guest. And let's run the exploit. So the function returned with 0, so everything went smoothly. As you can see, we just sent over the net user or a debug add command. And if we check on the server side, we have this new shiny debug user through Oracle. As simple as that. But we have another stuff. As you can see, the same happens. I'm just setting up the target database. But now I'm setting up a payload to a meter-peter bind TCP payload. Demogats. And as you can see, we have a meter-peter session in the Oracle process as a thread, in the Oracle process memory. So it's obvious this is the database. Okay, but how can we use, for example, this module through a hijack thread? There is a variable in this module called export, and I'm setting this to true. It won't connect to the remote database. Instead, it will create a file with the necessary debug poke command, a SQL file. For this, I need an address. And now we will learn how the module works. So we are going to use the already hijacked Oracle session, which still works. I'm initializing the debug. Thanks, typo. And as you can see, I'm just called virtual alloc, which is the memory allocation API on Windows. And I'm allocating 1000 bytes. And the access mask of the memory area will be read, write, and execute. I'm doing this because I wouldn't like to overwrite an arbitrary memory address in Oracle because it's dangerous. So now you have a own memory address space in Oracle. And debug is quite generous for us because it returns the return value of the given function. And the virtual alloc return value is the starting memory address of the newly allocated memory space. And of course, we need this address. Just if somebody at the back. And run the module. And as you can see, it just writes debug poke commands into a SQL file. It is how to write the payload into the Oracle process memory. And now we can call the SQL file from our hijack session. As simple as that. But we should somehow start the payload. And of course, we're going to use the create thread API. And of course, we need the address here. And as you can see, the session is still running. So the Oracle survived this. And now we need a handler, because it's a meter-peter bind TCP. And we have a new meter-peter session in the Oracle process memory through a hijack session. So as simple as that. But we are not finishing here. At the beginning of the presentation, Ferenc showed you what kind of function should be redirected or hooked at the client side. There are two other interesting functions that can be hooked at the server side also. And these two functions is used when the Oracle authenticates and the password encryption happens and the password decryption happens. And we have a tool or a Meterpeter extension load, sorry, for that one. And let's hook that two functions. From this point, if anybody logs into the Oracle, his password will be logged in a log file. I hope the log file is it's empty. Yes, it's empty. Okay, but we have a hijack session. It would be great if somehow we have the sysdba password, the sysuser password. We have his session, but if he can somehow have his password, it would be awesome. Let's do that. So how can we do that if we already have this authentication hooking stuff? The most simple way is somehow force the database to authenticate to itself through the hijack session. The most simple way is create a public database link named remote and using the given database service identifier. Because if you are using the given database service identifier in this command, the link will point to itself. So when I'm issuing a select against this newly created database link, I'm just forcing the database to authenticate to itself. And I'm getting the log file now. And as you can see, password encryption function, password decryption function, and the sysuser password through a hijack connection. And just recap what happened. We already had a hijack sysdba session. We injected a Meterpeter payload in the Oracle database memory. We didn't touch the disk. We load our Meterpeter extension and hook the necessary function. We created a public database link that points to the same database and forced the database, just selecting against this public database link, to call the hooked function. And after that, we just get the log file. As simple as that. So combining all of the things above, using a Meterpeter extension, hijack an Oracle session. What else? Use ORADBAC to inject the Meterpeter into the Oracle process memory, and at the end of the day, we get the sysuser password. And you have easy-to-use Metasploit modules now with some version affection. And be careful, this is the disclaimer, because Oracle is huge. The Windows executable is 130 megabytes, so be careful what are you doing in the memory. And we are not working with just Oracle. So let's see what we've done with MS SQL connections. History. There are lots of tools out there that can do something with an MS SQL connection. They can downgrade the encrypted authentication protocol, or they can log the credential data for later brute forcing, anything. But until now, there was no tool for hijacking. The normal way the victim connects to the database, authentication and data exchange happens in the database. You can initiate a classic cache poisoning attack, IP tables kung fu, and you can convince the client connects through the TDS proxy. Unfortunately, I couldn't find the exit or quit message in the TDS protocol, so therefore you have to tell the TDS proxy you would like to hijack this connection. In this way, the TDS proxy will close the connection to the victim, but won't close the connection to the database server. Instead, it starts a new thread, and when the attacker connects to the thread, the authentication will be simulated, and when the attacker sends a SQL query, it will be forwarded to the database and the same connection that was used by the victim, so the SQL query will be run in the name of the victim. And because of the simulation, you can use the normal MS SQL client here as an attacker. So this is Microsoft Word. So the TDS proxy has a graphical user interface. It's very nice, very polished, 3D everything. And you can use the Metasploit auxiliary MS SQL module to connect to the hijack thread. And we have a live demo. As you can see, we already started the ARP cache poisoning stuff, but it's not interesting. We hope it's working. This is the super polished 3D graphical user interface of the TDS proxy.
We worked a lot on that.
The most complicated part of the project. Okay, here is the server management studio, and we will connect to an MS SQL database.
Same complex password.
Okay, we connected. And we use the management studio because it's so good for hijacking, because it connects to the database several times. So if you just hijack one connection, the client won't notice it. So let's hijack the connection. I use the mouse.
Yeah, hacking by clicking.
And as you can see, new hijack thread started, waiting for connection on this port. And use Metasploit. The first example is the most simple Metasploit auxiliary module against the MS SQL servers, which is just issues a simple select. And as you can see, we are connecting to the hijack thread. The password is not important. And exploit. And as you can see, through a hijack thread, I just downloaded the username and the password hashes from SQL. Yes, not important. Absolutely not important.
Password is not
Because you have a hijack connection. You are after the authentication, and the thread simulates the authentication to you. And there is no any super magic cryptography in the, if you remember the XORing 0xA5 bit against the MS SQL password, why he goes through the network. So I'm just simulating that part. But it's not important because the thread will say as, okay, the authentication was successful, do your stuff. Okay, but you can use another Metasploit extension, or sorry, auxiliary module, just for the demo, because in every MS SQL hacking presentation, there should be the XPCMD shell. And this auxiliary module just supports that one. So I'm doing the same. And as you can see, it was successful. So through the hijack session, we just called, or hijack connection, we just called the XPCMD shell. So as simple as that. And as you can see, I just connected to the hijack thread several times. So the attacker go home or buy a SQL book and come back and connect again to the hijack thread. So some notes. We have to modify the MS SQL core mixin to work, to add some support for the newer protocols, because everything was tested on the MS SQL 2012 and 2008. And so for that, we have to modify this core mixin. If you would like to use the Metasploit auxiliary modules, you should replace the MS SQL.rb there with ours. But I think we will get a pull request or issue a pull request for that in the near future. You have to use the same client version that the client used if you are using the MS SQL clients to connect to the hijack thread. The TNS protocol is a quite huge animal. The TDS protocol is not so complex, but still complex. Or the clients are, I don't know, sensitive. And as I said, you can use the Metasploit auxiliary MS SQL modules. And this is the unnecessary slide, but every hacker presentation needs some network packets in it. So this is the network packets that you receive after the successful authentication MS SQL. And you can see a version number in it. And I'm using the version number, and yes, I fulfill the requirements to show code. I just added this two-line msql.rb to have this version information in the module, in the core mixin, and later on you can make decision regarding this version number. But as I said, it's not important. Okay, so we have still time. Summary. There was no SQL injection in this presentation, and we are very proud of it. We showed you what can you do at the client side with the DLL injection in the OCI driver. We showed you how can you really hijack an Oracle session with help of the TNS poison and PyTNS proxy. We showed you how can you use the Commodore 64 style to inject Meterpreter into the Oracle process memory. Don't touch the disk. And I think we proved we don't deal with just Oracle, so we are not just Oracle guys. Okay, and I hope everything that we just showed you, proof or point, it will think differently. Okay. But one more thing. So guys, we know that our presentation wasn't sexy because it doesn't have any supercharged SQL injection in it. This slide does not exist. Anyway, be patient. Anyway, this just how can you run operating system level commands through simple selects in Oracle. Just make the photo. It's quite simple anyway. Nothing complicated in it. But this slide does not exist in our presentation. Okay, did you have it? But anyway, so you don't have to make the photographs because the presentation on the internet now. So sorry, I didn't mention it. You can download it. So you will see the URL. So you should photo that slide. Okay. So, but we didn't show you any HTML5 JavaScript trickery or any mobile stuff. But we can help on the mobile stuff.
If you have
my mobile phone with me. Show you that.
Yeah. We have a fully paged Oracle server. Yeah. This is the resource monitor of this server. As you can see, the CPU usage and the memory usage. And
we have a very nice Android application. It's very complex.
yeah.
A big red button. And hope. I'm just pushing the button.
Yeah. Whoa.
So we don't know the distinction, but sometimes it consumes the memory, sometimes it consumes the CPU. This is only just one connection, pre-authentication.
So we don't know the username, we don't know the password.
Just send the packet. Or not more packets, sorry, but pre-authentication. This will be the second connection.
And sometimes it kills the Oracle.
After a couple of minutes.
Process completely. Oops.
Unfortunately, we cannot disclose the details because we didn't report this to Oracle. It's just 1 year old bug.
We are working on the advisory.
Yeah.
For a year.
For a year now. Sorry? Yeah. Okay, so some references.
Anybody from Oracle? It's good.
Okay, we are safe. But you don't know anybody there. You're already disconnected. Okay, thanks.
I'm not here.
Bye, friends. Okay, this is how can you reach us. Yeah. And get all goodies from that side. Yeah. And
thank you very much.
And you can download the slides also.
Yeah.
So just check it out. It's quite big now because we leave the animation in it. So it's 102 pages or something like that. So be patient. Okay, anyway, so thanks for your coming. If you have, so if you have any question, you can ask it. We won't answer it because we don't speak English, just Hanglish. But anyway. Sorry, can you just come forward on this?